Hello and welcome back to my YouTube channel. In this video, I'll be going through the solution to exercise 4.6 from the C programming language textbook by Kernighan and Ritchie. Now, exercise 4.6 says to add commands for handling variables. It is easy to provide 26 variables with single letter names, add a variable for the most recently printed value. So let's break this down. We're going to have commands for handling variables. So we're going to have variables in our calculator. It says we should use 26 variables with single letter names. So I'm going to just do the alphabetical or the alphabet. So A, B, C, D, E, F, G as possible variable names. And I'm going to make sure that they're all uppercase. And we should add a variable for the most recently printed value. Now this part is certainly the easiest part of the question. I have to be honest, this other part did take me a while to figure out. The solution isn't too difficult, but it's also not entirely clear immediately in the beginning. So I'm going to create a new variable for the most recently printed value, and I'm going to handle that first just because it's very easy. And I'm going to initialize it to -1 just to be safe. And here is where we print out our value. And now this is the most recently printed value that's going to be printed, and so I should assign it to most recent. So this is what I'm going to do, most recent equals pop, and then here we're just going to print out most recent. Okay, that's very easy. That's good. Now we need to handle the case for variables. So I'm going to create some variables. I'm going to create an array of doubles that are going to hold the variables. And they're going to be 26 because there's 26 letters in the alphabet. So for example, variables 0, like this will correspond to, I should comment this. This will correspond to the variable A. 1 will correspond to the variable B. So, and the 25th one, or the final one, the index at 25 will correspond to the variable Z. Okay, so that's straightforward. Likewise, I'm going to initialize this entire array to -1 just to be safe. And when I was thinking about doing this, what I found was it's probably easiest to change get operation. So here we do this, and right at the end we do this. We return a number, we've written a number. Now before I return here, I'm going to check if what I've read is a variable. So if it's a variable, it's going to be uppercase. So I'm going to use is upper. And if it's uppercase, in the same way that we return number down here, I'm going to have something else like return variable, which means that we read in a variable. Now this does mean we need to create a new constant called variable. So here I'm going to hash define variable, and I'll just set it to 1. And this is going to be a signal that a variable was read. Okay, so that means in our switch statement we're going to have to make some changes. So case, I'm going to have another case called variable. And now let's just think about this. The way that the variable is going to be used is like this. So for example, if we have 1a equals, this will assign the value of 1 to a. So this would be equivalent to writing a equals 1. Okay. But there's also the possibility where we can use it like this. Say we've assigned it, and then I do 1, 4 plus, oh, not 4, a. So this is saying 1 plus the variable value of a, which if I have set it to be 1, this will evaluate to 2 because a is set to 1. Now the problem with this, or an issue we may face, is that we need to know ahead of time what is the operand after a. So like I can't actually look ahead after I've written a and be like, oh, let me see what the next value is. If it's equals, I'm going to do assignment, and then if it's plus, minus, multiply, divide, whatever, it's going to be that respective operator. I can't do that. Once I've read an A, I shouldn't then go and read one more, then figure out what I should do, and then backtrack one. Like, obviously I could, but it's just unnecessarily complicated. So this is what I'm going to do. I'm going to assume that the variable has been set. I'm always going to assume this. And then, in our equals case, I'm going to fix up any possible incorrect assumptions. So let us just assume, for example, if we have variable that, for example, that A has been set. It may not have been set, but let's just assume it. So what is the variable? I'm going to create another value, char var, which is going to hold the variable value, and I'm going to initialize it to 1. And so var will equal that. It's quite obvious. In our get operation function, this will hold the value c, or the very first value that we've read in. Okay, and then I should push onto the stack the value of this variable. So it's going to be variables var minus capital A. Okay, so like for example, if var was b, capital B, b minus a is 1, and so we just get that index 1 element, or the second element. Alright, that makes sense. And then we can break. So this works if the variable has been set. But if it hasn't been set, it means that we are currently pushing -1 when we shouldn't be pushing it. Okay, so let's have another case. I'm going to have a case case equals. So if I have an equals operator, that means I want to assign. Or maybe the user has put in something wrong. Maybe they've put in 3, 2 equals, and I should tell them this is a problem, this is an error. So here's what I should do. I should say if var, if it's an uppercase value, then I can handle whatever. Else, I'm going to print an error message, and I'm going to say error invalid variable name. Okay. So if it's an uppercase letter, that means that our variable is actually there. We've read in a variable. Now the problem is we want to assign. But here, we've actually pushed the value of -1 onto the stack. And we don't want this, or whatever that variable was. I don't want to do an operation on that value. I want to assign something to that value. And so I should get it off the stack. So I should pop it. And then what's on the stack is going to be, what's left on the stack is going to be the value I want to assign. And so I can say variables var minus a equals the next element on the stack. And then here I should break. Okay. So for example, if we have something like 5a equals. So we have 5, it's on the stack. And then we read in a, and then we push this, which because a has not been initialized, we're pushing -1. So on the stack we have 5, and then on top of it we have -1. And then we read in equals. And then we go, not here, here. And we say, okay, 5a -1. So, sorry, 5 -1 is on the stack. And so if it's been set, this is true, I'm going to get -1 off the stack, and so all we have left on the stack is 5, and then I'm going to assign 5 to this variable. Okay, that was quite something, but let's just give it a shot. Oops, sorry. Oh, no errors. That's always good. And so I'm going to say, like, I don't know, 2a equals, so I'm assigning the value of a to 2, oh, I'm assigning the value 2 to a, and then I want to do 3 times a. And now I'm expecting 6. Nice. What if I do 5 E equals, and then I do 7 plus E, so something like this. I'm expecting 12. Nice. So it looks like it works. It wasn't the most straightforward or the clearest solution in the beginning, but it is quite simple. Now that will be all for this video. Thank you all for watching, and I'll see you all in the next one. Bye bye.